Welcome back. It's Mrs. Harris again here at Big Cat Inequality Rescue. We had something very exciting happen just the other day here at the park. We had a new cub born. So before we get into saga number 2, let's just celebrate, all right? Add him here to his friends. And then come on with me. We're going to go ahead and we're going to focus on testing solutions to inequalities today. So let's go ahead and get started. First thing we got to do though when testing solutions to inequalities is sometimes we have to go back and we have to write that inequality. So let's practice that first. It says t is less than or equal to -4. So I don't have any words here that indicate that an operation is happening to t. So we can go ahead and we can just write t less than or equal to -4. I'm still using that strategy where I go through and I look for key vocabulary before I write. So I have t is less than or equal to -4. Okay? Sometimes you're going to be given the inequality and asked to test solutions, and sometimes you're going to have to write the inequality first. So then, like on Khan Academy, I know sometimes you are given different solutions and you're asked to choose which are possible solutions. So I have -9, -11, 0, and -4. And I have to think about what numbers, if I substitute in for t, is going to make this inequality true. So I'm looking for any number that is less than or equal to -4. Well, right off the bat, you should say, oh, I know that -4 is equal to -4. So we're going to circle that as a possible solution. So then I think about, okay, what do I know about negative numbers? I know that the closer they are to 0, the larger they actually are. The further away they are from 0, the smaller they are. Just think about if you relate it back to money and think about debt. You'd rather only owe somebody -$4 than -$11. So I know that -11 means that I have a greater debt because it is smaller or further away from 0. -9 also means that. But 0, if I relate it back to a real world solution, is like even, breaking even. It means I'm not negative, I'm not positive, so I know I'm greater than -4. So 0 is not an option in this case. Okay? We have G is greater than or equal to 97. So again, I don't have a vocabulary word that indicates that some operation is happening to G, but I have G greater than or equal to 97. And remember that equal to symbol means that 97 could be a solution. Okay? But I'm looking for any number that is larger or equal to 97. So again, which are solutions? 0, 96, 97, or 98? Well, we know 0 is smaller, so 0 is not a possible solution. Okay? 96. If I were to substitute 96 in here, it would say 96 is greater than or equal to 97. Is that a true statement? No. So that means 96 is not a solution to this set. Then I have 97. If I go back and I substitute it back in, so some of you may need to do that. You may need to go through and physically substitute in the values every single time to test. So 97 greater than or equal to 97. Well, it's not greater than, but it is equal to. So 97 does work as a possible solution to this inequality. And then if I'm comparing 98 and 97, I do know that 98 is greater than 97. So I know that for the solutions that I was given, that 97 and 98 are both possible solutions. All right. Y is less than 12. So we have y less than 12. Y less than 12. And it's really helpful. I like to underline again because I know that I can replace the parts that are underlined with whatever symbol is needed. So I know that less than means that I'm comparing y and 12, and I know that y has to be smaller than 12. So the question is 14 a solution? Well, I can go and I can substitute in 14. So if I were to rewrite it, 14 less than 12. Is this a true statement? No. So we can say no, 14 is not a solution.